Fine. Alright. Same for this video. Again, I'm going to explain, okay, by using a graphical method to show that the roots of the equation, approximate the roots of the equation. So never mind, I'm going to using this question also to find the approximate roots of this equation. So now, as I have x squared minus 2e to the power of negative x, right? So I can rewrite this equation if I want to using graphical to determine the number of roots, or we want to know where the roots locate. So we have to rewrite this into two different functions. So I separate because this is a quadratic function and this is an exponential function. So I make it one side to be exponential and the other side to be quadratic function. So that I can sketch the graph, right? So I already sketched the quadratic graph. You know how to sketch, right? X squared passing through 0. But because I'm using graph paper, it will be help me with more accurate in approximate the roots. If you're using paper, right, you better using ruler, right? Ruler. Really, you go and measure, right? Measure. So rough cannot be sketching roughly, no. Alright. So now I'm sketching the graph of x squared. Okay, the graph of x squared to solving this equation, and 2e negative x. So x squared I'm sketching, negative 2 I have 4, 2 I have 4, right? 3 I have 9. Right, and I am plotting the graph and I am sketching the graph. So now this is the point that I plot. So when x is 1, so it will be 0.7 something. Alright, when x is 0 for this graph, now, so you're getting 2, right? And for negative 1, you are getting like 5 point something. So never mind, with this point is enough. So now I can sketching both graphs. So I want to see where they intersect, right? So where they are actually intersecting here. So from your eye, where can you see, right? Exactly where they intersect here. So I bring over, so you can see that. So you can see that the graph is actually intersecting between 0 and 1, but nearly 1, right? It's between 0 and 1, or I can say the interval of the roots will be between 0.5 and 1, right? 0.5 and 1, right? Or you see that the intersection point here, right? I'm going to put a pin point. I'm going to pin it here. Can you see that? It's between. So I can say it's like 0.9. It's like 0.9. So if I from far I can see like something 0.9. But is it 0.9? The question is it 0.9? So I can say, for now, if people asking me, what is the approximate root? What is the approximate root? Penghampiran punca, okay? Approximate root, I can say x is around, okay? I put x1, but it's around 0.9. But is it 0.9? This is the question, right? Is it exact 0.9? This is the question here. Right, the question mark here. So no, I can tell you no. Okay, by plotting the graph is not enough accurate. Alright, that's why we need some special method in this chapter, which we call, because we want to solving the equation. For this case, we want to solve the equation of x squared minus with 2e power negative x equals 0. This is a non-linear equation because there is a mixture of quadratic and exponential function. This is hardly to have any specific method to solving this. So that's why we need numerical method. So we need Newton-Raphson method in this chapter. So how to finding this value? So okay, I'm going to introduce you with this apps. Okay, the same again I introduce, but this time I want to introduce you something. Okay, just now I'm using my screen, so it's a bit blur. So now I go to setting, I reverse the I put it to projector mode and I reverse the contrast. Just now I just learned. Alright. So you see, so now I'm going to sketching. Okay, I'm going to sketching the. Okay, I don't want the projector mode maybe because it's hardly for me to zoom. Okay, so now I have this. So I want to key in the equation, right? So this equation will be this one. I'm going to combine the two graphs. So x squared. So alphabet x squared, right? Alphabet x square, right? X square minus, okay, minus with choosing the function here, okay, the function here, MISC, right, miscellaneous. Okay, so you have ln, you have log, alright, sorry, so back, Okay, so go to function, choosing exponential, exp, right? Exponential, put a bracket. This is power of negative x. Okay, sorry, there is a 2 in front here. Alright, there is a 2 in front here. 2e to the power of negative x. So that's all. Right? That's all. You have key in x squared minus 2e to the power of negative x. Okay, now you see, look at the graph here. Right? Look at the graph here. So you can't see, right? So you zoom in. So where's the roots? From far you see like passing through 0. Okay, and I'm going zooming in again. As usual, okay? I'm zooming in. So now I'm going to the... Okay, I'm zooming. And I can see that it's between 0.1 and 1, right? The x-intercept. Alright, the roots is the x-intercept. So it's within 0 and 0.5 and 1, right? Just now from here I know it's nearly 1, right? I don't know. So from here I can maybe see better. Yes, it's like exactly 0.9. Do you think it's true? The question here, do you think this is true? No. You think it's 0.9. No, you zoom again. You zooming again. Okay, you can see that it's not 0.9. Okay, I'm not going to zoom again because if you keep zooming, it's more detailed. Alright, so it's 0.9 and 0.902. Nearly 0.9 lah. Okay, that's why you see during when I'm sketching here, I see it's like nearly 0.9, but it's not 0.9. The exact value is not 0.9. So through the apps, I can say it's between 0.901 and 902. But how can you bring this calculator into your examination hall, right? Yes or not? So never mind. Without the apps, human can still alive. Means that we still can alive and solving mathematics. We can using Newton-Raphson method. Later on, I'm going to introduce this method. Very powerful method. You can using that formula and obtain the roots. You obtain the roots. So okay. Then the question said find the number of roots. How many roots here? How many roots you have? So if you're sketching the graph from here, I can just found to be 1 roots. 1 roots between 0 and 1 or 0.5 and 1. There is a roots, and the root is approximate 0.9. Alright, I think that's all for this.